So let's go on a little bit of a clean room journey. Okay, we didn't start out being a clean room robot manufacturer when we started making robots in 1967, but this will give you an idea how we got there and maybe give you some insights into what clean room robots are about. Okay, this is a guy inside a clean room with his arm inside another clean room. So he's probably in an ISO 5 or 6 clean room, and he's got his arm penetrating into an ISO 1 or 2 clean room. So it just gives you some ideas about what it's required to make a clean room clean. Okay, a little bit about DENSO first. DENSO is a $50 billion manufacturer. Our job is to make automotive components for every car maker on earth. Um, we have over 150 plants with 2,700 production lines running every day, all day. And we've been making robots since the 60s, and we've got about 27,000 robots installed in our factories and 143,000 robots installed globally. So pretty good size in terms of robots. DENSO makes over 100,000 different components, most in the automotive area. So systems like electrical, fuel, uh, pollution control, electronic braking, cooling, air conditioning are all DENSO. We'll make a complete system for a vehicle. And that's the majority of our business. The non-automotive side, where robots are, tend to be products that we've made to help us make the auto parts. So robots, uh, portable air conditioning, which we invented to cool the people and the processes in the factories, and also things like QR code, which DENSO is the inventor of. So we're sort of, you know, a company that figures out what we have to do and then builds the products that we need to make those products. As we move into the future, DENSO, being an electrical component manufacturer, is uniquely positioned to be able to take care of vehicle electrification, automotive driving, automated driving, artificial intelligence, which is the driver to make all that work. And we've invested heavily in quantum computing, which is what's going to be needed to process all that data. So we're in a very good spot as a company and positioned to be into this next generation of vehicles for the future. I forgot to mention, vehicles are now becoming more of what's called mobility. So it's no longer just your car to go drive, it's mobility, how to get from place to place. And we'll be working in systems, not just vehicles, to enhance that in the future. Okay. Let's go into clean rooms now. It's essentially a controlled environment where you keep out dirt, dust, junk, and you're able to control the airflow, you're able to control the temperature, the humidity to do specific processes. And where do they use clean rooms? Almost everywhere. Medical device, for research, for pharmaceutical, for medical labs, electronic parts production, including automotive, anywhere where you can't have contamination. So when you think of clean rooms, sort of think of keeping contamination out of the environment. Okay? Let's go into a little bit of giving you some tools to understand clean room. You may have heard class 10, class 100. That was an early explanation that was an SAE style, which utilized the number of particles in a cubic foot of air. The ISO standards, which is what everyone's developed around the world, is the number of particles in a cubic meter of air. And I've created a little bit of a classification here of the difference between the ISO and the class, so you get an idea. And also you get an idea of how big of particles we're talking about. Okay. So if you're looking at an ISO 3 clean room, there can't be more than 1,000 particles under 0.1 microns in the clean room in a cubic meter of air. Just for reference, coronavirus particles are about 0.12 microns. When we look at clean rooms in general, when you start, people start throwing around clean room specs. Here's an idea down here, ISO 9. That's essentially room air. That's your house, your office. ISO 8 is when you begin to get a little bit of cleanliness. So you may find people with jackets on. ISO 7 is when things start getting more serious and you start having to get more and more protection. And we'll take a look at this as we move forward. But this is a handy chart to keep around so you get an idea of what people are talking about. And when you start hearing ISO 5 and ISO 4, that's very serious. Generally, you don't see people in those areas. While we're talking about cleanroom, I wanted to give you some visibility on IP rating as well. Because a lot of times people talk about IP and they talk about cleanroom, and they're kind of the opposite. Cleanroom robots are designed to keep everything in the robot and not coming out. IP robots are designed to keep things from getting in. So the seals are actually in the opposite directions. Okay. Now, while you'll see ISO 3 and ISO 5 robots around, ISO 5 robots that we make are generally sealed, which means you don't need to apply any vacuum to keep the cleanroom rating. And something that I've seen is that when you look at the process, you want to make sure that what's in the cleanroom is not going to create an issue if it gets into the robot on an ISO 3 application. Because if you get anything bad inside the robot, like abrasives or corrosive material, you can create what's called, I don't know if this is an industry term, but robot juice. So if you have caustic solutions getting inside the robot because you're applying constant suction to keep a ISO 3 rating, it'll start to eat up the inside of the robot, and eventually robot juice will leak out. It's kind of funny, but it's happened before. So you need to look at the environment. Generally in those type of applications, you'll use an ISO 5 robot, which is sealed. Okay. When we start to talk about IP ratings, those are designed to keep things from getting in, and the seals are turned in the opposite direction. So they're not necessarily very clean. Okay, but so you need to determine, are we worried about things getting in or out? Okay. As you look at the environment when you're going in, an ISO 9, which is room air, I don't know if anybody has kids at home, but a kid's room is probably ISO 9, which means it really isn't, it's got a rating, but it doesn't mean that it's clean. It just gives it a number. That's typical room air. When you start looking at an ISO 8, which is the first level of clean room, you'll see nice floors and maybe people with some coats on. Okay, and it'll have to have some kind of filtration to maintain that. When you start talking about ISO 7, which is not very far into the clean room area, 10,000, you'll start seeing people with hoods on and masks. Okay, so a lot of times the customer will tell you that, or you may hear, oh, we need an ISO 5 or ISO 6. But when you start looking around at the environment, you see people around and it's not ISO 5 or 6. So you need to determine what it is that you actually need to keep your process safe. When we start looking at ISO 6 and 5 and 4, the clothing starts getting very serious and the entry and exit points become very difficult. In order to get into an ISO 5 cleanroom, you probably need to go through a couple of antechambers in order to be prepared to get into it. So this will give you an idea of what you'll be seeing when you're trying to figure out where you should be on cleanroom. Okay, so if you're trying to do a class ISO 5 or 4, you're completely covered from head to toe. Double gloves, coveralls, mask, goggles, in order to keep you from contaminating that environment. So a quick and easy thing to look at is, what are the people wearing in the process? So if they're able to just wear a coat and maybe a head cover, it's probably ISO 8. When you start seeing masks and goggles, you were getting into 7. And when everything's covered with double wrap, you start looking at 5 and 6. So it gives you a good idea of the rating that you need and how to apply the correct robot. If we look at what we have for tools, and these are the robots that you'll have available for your applications. So you've got Scara Robots. We go from 350 up to 550. These are all ISO class 3, which means they have suction applied to them to create a very, very high level of cleanliness. And those are available in, as I mentioned, the 350 to 550 Scara. We also have a J series, which is bellows only. And while it's not rated as clean room, when we test it, it's about class 10,000. So that is many cases the appropriate answer for most medical device manufacturing. Instead of having a full clean room, generally they're able to use the uh, J series. That's also available on our HSR series. They have an ISO class 3 as well as a J series. And that range goes from 480 up to 650 millimeter. Okay. Okay, so that's a little bit of the Scara series. We do have some heavy lifters. If you need things in the 1,000 millimeter to 600 millimeter range at up to 20 kg, the HM series is appropriate for that. But we don't make it in a clean room. But when we test the dust and mist-proof series, we do see about a class 100,000. Okay, and we move into our 6-axis series. We go from a 430 millimeter up to a 1.3 meter. And we do have variations in that area for ISO 3, ISO 5, class 100, and class 10 clean room. So there's a very, very deep and wide range of standard and clean room robots in our articulated arm series, as well as a very special robot I'm going to talk about in more detail, which is our pharmaceutical robot. But when we tested even our standard robots, we get some pretty good ratings just looking at how clean they are. When we test our standard 6-axis arm, it's about class 100. Even though it's not rated as that way, and we do sell a rated version, but just from our own internal testing, we find that our standard robots are pretty clean, which is why we end up in a lot of applications for medical device and pharmaceutical and life science, because just the standard product we make is good enough for what they want to achieve. The special robot I talked to you about was the DENSO Pharma robot, and that particular robot is capable to handle up to 37% H2O2 vapor, which is the de rigueur ultra cleaning method now for cell production environments, for regenerative medicine. Also, it can handle spore cleanse and some of the really strong cleansing agents. That particular robot is class 100 clean room, as well as, or ISO 5, as well as an IP65 sealed robot. It is one of the most interesting and specialized robots we've ever made. And it's got no bioburden points on it anywhere. And it also has internal electrical communication, so you can run a full servo gripper or sensor package on the end of arm with no external wires. This is something that hadn't been done before, and it's a very unique feature because these type of environments, once you close them down, you don't want to spend any time opening them up again. It takes weeks to clean out the inside of the cell. This is an example of 4 of these robots at a trade show. The ones with the lights on are the UL versions, doing a simulated cell mixing and pouring. But quite impressive looking robots, I think. So when we want to apply a clean room robot, here are just some things to consider. Look at the operation. What do you see? What's the actual environment going to be like? What are the materials that are going to be in there? Are there anything that's going to be created from the process? Is it dry? Is it humid? Any particles there? Is the robot in a hood? Because many times you can have the robot in a clean room in a separate environment that has a much higher clean room rating. Okay, so that's something to look for as well. And is the robot going to be used in operations pre or post sterilization? Because a lot of times if you're doing gamma sterilization or gaseous sterilization, that takes a lot of load off what you need to be concerned about. Okay, so if you know the actual requirement, you can match the available equipment to your process. Okay, so a lot of times you don't need a clean room. So you want to determine that to make sure that you have the appropriate equipment available to the customer. But if there's a mandate where you need ISO 3 or 5 or class 10 or 100, those are all available from us. So to sum it up, we've been making robots for decades, and clean room ones as well. So we have a lot of experience with this. When we say it's class 10 or it's ISO 3, that's how it is for its life. Okay, we have a 4-year warranty on all robots in the United States, except I think the low-cost Scara that we make and one of the little collaborative guys. But other than that, everything is 4-year warranty. So that way you know with confidence that we know that robot's going to perform, and it's going to perform to the spec that we rate it at. Okay. Who's using our cleanroom robots? Recently, I just kind of checked out the alphabet of our customers, and pretty much A to Z, Abbott to Zeus. We've got a tremendous amount of people that have been using our product with very good results for many years. So when you want to specify a cleanroom robot, understand the process and the environment, and you'll find out that you can apply the correct tool to that to solve the problem. Okay. Remember that class 3, ISO class 3, and class 10 cleanroom use suction to achieve their spec. So that may be an issue in some applications, so you want to pay attention to that. Okay. In that case, sometimes ISO 5 or class 100 may be a little better, especially on some of the medical device where they generate particles. So just a few interesting pictures. This is an idea of some mobile cleanroom robots that we made. This was a class 1 mobile cleanroom robot, pretty interesting. This is a mobile robot in our wafer fab where DENSO makes 100mm wafers for the automotive industry, so we can make our own chips for the cars. In case you ever wondered how come your suspension system is so smooth on your Lexus, it's because there's custom electronic chips made to provide that smooth ride to you. Okay, pretty cool. Anyway, also this is an example of an inverted HSR cleanroom robot. I put together some appendixes for you, and this you'll be able to get a copy of this presentation. And I put together a couple of different things that you can read up and increase your knowledge about cleanroom, and also about what that market looks like for the future. In addition, just in case you were curious, I know a lot of you are engineers and you might want to know what do we do different to make a standard robot and a cleanroom robot. So here's some examples of some of the older robots that I was able to get declassified, so you could take a look and see what the difference is. Because when we make a cleanroom robot or an IP rated robot, we make it from scratch that way. We don't add a kit on. So this is kind of interesting stuff for you. And this is something useful that we've used in the pharmaceutical area, approved cleaning processes. So I know a lot of people want to have a maintenance daily on the robot, and this is what has worked very well and has not created any issues on the robot over its lifetime. So isopropyl ethyl alcohol, sodium hypochlorite, which is bleach, and sterilized water. That's been a very effective way of keeping the robots clean, and most people have been very happy to be able to use this. It's worked pretty good for them. Okay, I wanted to thank you for listening to us on this. I hope this provided some information and insight to you, and also maybe a reference tool that you can use in the future when you're trying to understand how to take care of an application you're working on. All right. Do we have any questions?